Welcome back. Now we're going to talk about systems of linear inequalities. So a system of linear inequalities is similar to a system of linear equations, except that you have inequality statements rather than equations. The solution to the system will be the region where all individual linear inequalities overlap. So you're looking for the area of overlap. So to graph a system of linear equations, that should be inequalities there. Here, I'll fix it real quick because that's going to bug me. So you're going to follow these steps. Inequalities. All right. Oh, now it's misspelled. Goodness gracious, I need to get it together. All right, there we go. To graph the system of linear inequalities, finally, follow these steps. Step 1, graph each inequality in the system. You may want to use colored pencils to distinguish the different half planes, plus it just makes it pretty and makes it more fun. So bring map colors with you if you want to do that, especially to class when we work on our rounds. For step 2, identify the region that is common to all graphs of the inequalities. This region is the solution of the system. If you use colored pencils, the graph of the system is the region that has been shaded with every color. So that's going to be the solution. Okay, so let's look at some examples. So this is from section 3. We're actually skipping section 2 for just a little bit. We'll come back to section 2 next time. We're going to learn how to solve just the linear systems of linear equations algebraically, but I thought the two graphing sections went together well. Okay, so you've learned how to graph a single linear inequality, and remember the idea there is you're going to check to see if you need a broken boundary line or a solid boundary line, and then you're going to test a point to see where you need to shade. If 0, 0 is not on the boundary line, that's a great point to check because it's real easy to plug in and evaluate. So we're going to graph the system of inequalities. We've got y greater than negative 2x minus 5. And so we know that one's going to get a broken line because it's strictly greater than. Remember, you only do solid lines for or equal to inequalities. And that one doesn't have an or equal to, so it doesn't get a solid line. It gets a broken line. Now for inequality 2, we've got y less than or equal to x plus 3. So we're going to graph that one, but it's going to get a solid line because of the or equal to. So take a few minutes, just like you did with equations, stop and graph. This time it's going to be real easy to use slope-intercept form. So put the y-intercept on the y-axis and then use the slope to get a second point. And then we'll meet back here. Go ahead and pause me. Okay, so for the first one, you would plot the point 0, negative 5, and then use the slope of negative 2 to get to a second point, and you would draw in a broken line. Okay, draw in a broken line. I used red for y greater than negative 2x minus 5, and then blue for y less than or equal to x plus 3. Like I said, it's helpful if you use 2 different colors. If you don't, if you just use one, make sure it's clear where the overlap is. So you can see this first one is the red one. We've got our nice broken line. You can see it goes through negative 5, 0, negative 5 there. And then from there, we went up to left 1, up to left 1, up to left 1 to get other points. Drew in our broken line. If you test 0, 0, you get 0 greater than negative 2 times 0, which is 0, minus 5. 0 is greater than negative 5, so we shade on the side with the 0, 0. Okay, and so that's the red shading. Now, for the second inequality statement, y less than or equal to x plus 3, you can see we've plotted the point 0, 3, and we've used a positive 1 slope. So you can go up 1 and to the right 1 to get a point on the line, but remember, negative divided by negative is positive, so we can go down 1, left 1, down 1, left 1, down 1, left 1, and so on, and we draw in a solid line, a solid blue line, because of the or equal to. Okay? Again, plug in 0, 0, so we get 0 less than or equal to 0 plus 3. 0 is less than or equal to 3, so we shade on the side with the 0, 0. And what's cool about using two different map colors is that, like in this case, red and blue make purple, so the purple region is the graph of the system. So the graph or solution of the system is the intersection of the red and blue regions, which makes a lovely purple shade. Okay, let's look at one more. Okay, so, well, first, identify the region that is common to both graphs. It is the region that is shaded purple. If you're just using a regular pencil, it should be clearly darker than the areas where only one system was shaded. It should be really easy to tell where the overlap is. Okay, so we're going to graph this system of inequalities. Same kind of process. So we've got 2x plus 3y is less than 6. And then y is less than or equal to negative 2/3 x plus 4. Okay, so that again, the first equation, first inequality is going to get a broken line because it doesn't have the or equal to part to it. The second one's going to get a solid line because it's less than or equal to. The or equal to part is what determines that you have a solid line instead of a broken line. Okay, now you need to go ahead and graph each of these inequalities separately. When you go to do the boundary line of the first one, it is in standard form. So I went ahead and found just the x-intercept and y-intercept. So when I plugged in 0 for y, because that's how you find an x-intercept, I got 2x equals 6, so x equals 3. So 3, 0 is my x-intercept. For the y-intercept, I plugged in 0 for x, and I had 3y equals 6, so y equals 2. So 0, 2 is my y-intercept. So I plugged in, or I plotted rather, at this point in blue, I plotted the point 3, 0, and, in red. Sorry, got it backwards. In red, I plotted the point 3, 0 and 0, 2, and I drew in a dotted line because it's strictly less than. If you test the point 0, 0, you get 0 less than 6, which is true, so you shade below. So that's our first inequality statement. Our second inequality statement, when we go to do the boundary line, y equals negative 2/3 x plus 4, well, it's in slope-intercept form, so I just go to 0, 4, and then I apply my slope of negative 2/3, so I go down 2 to the right 3, down 2 to the right 3, and draw in my boundary line there in blue. It is solid because of the or equal to part. Now, when you try 0, 0 for this one, you plug in 0 for x, you plug in 0 for y, and you get 0 greater than or equal to 4. That's not true. So we shade on the other side of that blue line, not on the side with 0, 0, but the other side. Now, the red and blue regions do not intersect, so your final answer for this graph is no solution. There are no points at all that make both inequality statements true. So this system has no solution at all. Okay, guys, it is now time for you to try some problems on your own. Not a whole lot that's super new in this lesson, just kind of doing some things we learned in Chapter 2, just doing 2 at a time, and then using what we get from that to come up with a solution that makes 2 statements true at once, when it's possible. Sometimes like this one, there's just no solution. Okay, guys, try those problems on your own. Next time in class, we'll go over those, and then you'll be ready to start your rounds. See y'all later. Have a good day.